Hi, Professor. So I'm going to explain the code here. Let me see. Our first requirement is to implement the mean square arrow and the cross entropy and log likelihood. So the code is here. So these two I just copied from the network 2. Yeah, just copy from here. So I think this is correct implementation. So I just copy them here. I just need to make sure the A and Y is corresponding to the network 2. So inside this loop for the test data, so I first store A by the feed forward propagation of x, and then I accumulate the mean square errors, the cross entropies, and the likelihood for each test data, and then I will take the mean of them and the return. Yeah. So the only one I should write myself is the log likelihood. So it takes the y index. So y is the argmax y here. It's the correct label y, and we just want to see what's the log likelihood of that one, because A is a list of lists, so I need to get the value of the probability. So I return as a list, as you can see here. Yeah. So this is the second requirement I'm going to explain. It's in SGD. So I just modify the print here by just this one, and also this one here, and we get the chaining history. So I have a chaining history here as a list to store the history, and I can get one and then append to it, and finally I can return the both list here, and I almost the same operation for training, for the test and training here. And yeah, and the second one, I just explained the first one and the second one, and the third one is early stopping. So for early stopping, we just compare the value after all the evaluation and compare the accuracy. Yeah, the fourth actually the index 4 is the fifth element in the list is the accuracy. If it's greater or equal to 10%, then we break this loop and return the result. Okay, now for the third requirement. So we just change the activations here. I'll explain it by like debugging mode. So the first we create a empty list for activations, and we fill them with zeros according to the size we have here. It's 3 layers, and for each layer we go through 3 layers, and for each layer we fill with zeros to the activation result. So let's go through this. Let's take a look at the change of the activations here. First we can with 4 zeros for the first layer, right? For 4 nodes for the first layer, and then the second layer is 2 here, and the third layer. So yeah, and then we fill the first layer with x, our input, and it's become this, and then we go through all the layer. This I means layer number, and then the combination of we zip it, so we can get the each layer's biases and weights, so we can fill out all the activations here. So like this. So you see, so the second layer actually is the second layer, and it's filled with values we got from the calculation. And the second one is, you see all the values has been filled out, all the like activation values, and we jumped out, and then we do the back propagation path. So the feed forward is down. Yeah, thank you.